Okay, so the first thing I want you to write is any number or variable raised to the power of 0 raised to, get this chord out of the way. Whatever. Okay. Is equal to 1. This is Mr. Church. Oh, yeah. Okay. Bye-bye. Okay. Any number or variable raised to the power of 0 is equal to 1. For example, 4 to the power of 0 is equal to what? 1. Pretty straightforward, right? Get that copy down real quick. 1 sec, Angel. Okay. Sorry about that. So, 4 to the power of 0 is equal to 1. If we have negative 13 to the power of 0, that's also going to equal 1. If we have 3,265 raised to the power of 0, again, that equals 1. And please also write down all these examples because you may be like, I'm not going to forget that anything raised to the power of 0 is equal to 1. But you might accidentally misremember it as equaling 0. That happens more than you would think. So please make sure that you're writing all this down. And finally, if we had 3/4 to the power of 0, that's going to equal 1 just the same. Even though it's a fraction, it's also going to equal 1. That's the first half of our notes. Not too bad, right? The second half is much longer, but it's okay. At least the first half is a nice, simple concept.
How long are we taking notes for?
I'm not sure. It shouldn't take more than 10 to 15 minutes. Any questions on 0 power? Okay, good. It's probably the most straightforward thing we'll learn this year, so let's get it down. Second thing is when a number or variable is raised to the power of a negative exponent flip the numerator and the denominator keep the exponent the same, but make it positive. And this definition doesn't really mean anything until we see it in action, so don't try and read too deep into it just yet. For now, let's just get it copied down. So, our first example. If we have 3 to the negative second power, 3 to the power of negative 2. Everyone okay with that level of zoom? Are we all done with the 0 exponents? Good. So when we raise positive 3 to the power of negative 2, all we have to do is flip the numerator and denominator, keep the exponent the same, but make it positive. Do you guys see a denominator in this problem? Do you see a denominator? No, we don't. But is there a denominator, Noah? Yeah, what's our denominator here? 1. Exactly. We can rewrite this as 3 to the power of negative 2 over 1. Any whole number like this has a secret invisible denominator of 1, because anything over 1 is equal to itself. So we can rewrite it as a fraction just to make the flipping easier. We'll talk about a shortcut after we get through this. So we're going to take our numerator and our denominator, and we're going to flip them so that we now have 1 over 3 to the negative second. And the last thing we have to do is just make our negative exponent positive. 1 over 3 squared. Thumbs up if you're with me so far. Good. I'll give you time, or I'll give you plenty of time to write and think about this. I'm just going to add in a little note here. To make your exponent positive, then I'll put a box around our final answer. Now, technically, we should take this a step further and simplify our denominator, giving us a final answer of 1 over 9. But since we're just worried about learning how to do this whole negative exponent thing, just leave it like this for now. That's completely fine. And on your worksheet that we're going to get here in a couple minutes, leave your answers like this with the exponent. It'll help me when I'm taking a look at your work. All right, what about example F? example F. Let's do x to the negative fifth power. X to the power of negative 5. Once again, let's rewrite this so that we have a fraction here. X over, what's our denominator going to be? 1. It's always going to be 1 if our number is a whole number. We'll take a look at using a fraction next. We'll put x to the negative fifth power over 1. Once again, we're going to flip our numerator and our denominator. It's going to equal 1 over x to the negative 5. And then we make our exponent positive and get a final answer of 1 over x to the fifth. Take a look at example E, or actually, you know what? I'm going to let you write. Just to clarify real quick, right here where I say to keep the exponent the same, all that means is don't change the number. So we're technically not keeping it the same by making it positive, but I mean keep the actual number that the exponent is the same. So x to the negative 5 will never equal 1 over x to the fourth. You see what I mean? So keep the number the same, but just make it positive. So take a look at the starting points for examples E and F. 3 to the negative 2, x to the negative 5. And then take a look at our answers for both of those. Do we see any type of pattern here at all? Do those questions and answers look familiar to each other? Can't see. You need to move up maybe? Oh, my bad, okay. I thought someone said they can't see. Hopefully you do see the pattern in that if we have a whole number or a variable raised to a negative exponent, your answer is just 1 over that with a positive. It's just 1 over this with a positive exponent. 1 over this with a positive exponent. So if I gave you example G and said maybe 10 to the negative third power, we can skip all these middle steps and just say that this is equal to what? 1 over 10 to the positive 3. Exactly. So in examples E and F, these are like the breakdown of how we use this definition, the steps, right? But once we start to recognize these patterns, we can just jump right to the answer. Okay? Let's take a look at example H. Let's do 2 over 3 to the negative second power. Now we have an actual fraction, right? What was the first thing we have to do when evaluating a negative exponent again? What's that? Bingo, exactly. Flip the numerator and the denominator. So let's do that. Let's flip it. Now we have 3 over 2 raised to the power of negative 2. Okay, we did the flip here. Then we can make our exponent positive. Positive 2. And when we are squaring a fraction, think back to our warm-up today. Right? This is exactly what we were doing, squaring fractions. We could expand this out to be 3 over 2 times 3 over 2. Or we could put this exponent on both the numerator and the denominator, which is called distributing. Has anyone ever learned about distributing before? Maybe? A couple people. I see some people shaking their heads. Not sure if you learned how to distribute yet, but we'll get there later on in the year too. So we can just leave our answer like this, 3 squared over 2 squared, or we could make it 9 over 4. But for now, this is all I'm looking for. And then I'll just add in here. If you already know this, you don't have to write it. Distribute exponent to both parts of the fraction. All right. Okay. Last example, and then we'll get right to work. Told you it wasn't going to take very long. A, B, C, D, E, F, G, H, I. Okay. Sorry. I don't know my alphabet. Example I is let's do 2x to the power of negative 3. Now we're getting a little bit complicated. Take a look at example H and example I. Is there anything super different about H and I that we notice? Is there anything missing in I that's present in H? Jordan?
The denominator.
Okay, good. We have a denominator up here, but not down here. Great. Good observation. What else is missing in I? Jordan, you see something else?
The parentheses.
There we go, the parentheses, right? We have parentheses here and the exponent outside the parentheses. But here our exponent is not outside the parentheses. Why is this important? This means that negative 3 is not attached to the 2 at all. The negative 3 is only attached to our x. So if we wanted to write this as a fraction, we could write it as 2x over 1, and x is raised to the power of negative 3. And this is going to equal 2 over x to the third. Now I know that may look a little confusing to you. Let me explain how we got to this point. Imagine the 2 is not there, right? Just imagine the 2's gone. Our answer would be 1 over x to the negative 3, right? Oh, sorry, 1 over x to the positive 3. Well, we have twice that amount. Whatever that amount is, because of this 2 here, we have twice the amount. So instead of 1 over x to the third, we have 2 over x to the third. We don't flip this 2 down, or we don't bring it down to the denominator, because it's not attached to this exponent. It's attached to the x, but not the exponent. Is that confusing at all? Okay. So only flip what the exponent is attached to. With example H, the exponent's attached to our whole question, right? 2 over 3. It's attached to the whole fraction, so we can distribute it to both terms, the 3 and the 2. But here, we can't distribute it to the 2 because it's only attached to the x. I know I said this was the last example, but because I feel like that's confusing, Hij. We'll do one last one real quick. Let's do 5y to the negative 1. (5y to the negative 1). Based on our example I, what is our numerator going to be for our answer? Based on example I, what would our numerator here be? Y? It's going to be 5, right? Our coefficient stays as the numerator. Our coefficient stays as the numerator because that negative 1's not attached to it. We bring that y to the negative 1 down, and when we do that, it makes our exponent positive. Y to the 1, thank you if you don't mind, sorry. Y to the first power, well, that's just the same thing as y, right? So we can write this as 5 over y. Thank you, Dominic. We can write it as 5 over y. We don't need to write to the first power. And that's our answer. 5 over y. How are we feeling? Show thumbs. Thumbs up if you're feeling pretty confident with this. Thumbs sideways if you may need some one-on-one help. And thumbs down if you are kind of just lost a little bit. It's okay if you are. I'd just like to know. Okay, I see lots of thumbs up, which is great. And if you, aren't feeling very thumbs up right now, but you just didn't want to say it, that's all right. I'll be coming around when you guys are working to help each of you.